Welcome to ClickMyProject.com. Our project title is Coordinated and Adaptive Information Collecting in Target Tracking Wireless Sensor Networks. Abstract. Energy conservation is an important issue for many applications in wireless sensor networks. For data gathering in a clustered sensor network, most existing system focuses on fusing data at cluster heads. In target tracking application, these approaches do not consider that one target is usually detected by sensor nodes in multiple clusters, which leads to redundant data transmissions from CH to the sink so as to wastage of much energy. To solve this problem, propose a coordinated and adaptive information collecting strategy that is called CAICS for target tracking in clustered WSNs. In CAICS, a coordinated node selection method considering the spatial correlation of sensing nodes is proposed to dynamically select the best set of nodes for tracking missions. Let us see the flow of our project. First, node is deployed in wireless sensor network. Then the sensor network sensing the range. Our transmission range is between 600 cross 600 meter, and we have to implement the CAICS based upon the tracking node selection. The node which is in tracking node, we have to select an aggregation node based upon the energy and distance. The node which have the highest energy and highest and the shortest distance selected for aggregation node. Then we have to do the proposed work, that is for security implementation. So if malicious entered, we have to implement the security using RSA algorithm. It generates the key for all nodes. The node which is act as a malicious doesn't have any key information, so we have to identify that node and block list from the network, and we have to do the analysis part, that is for energy, packet delivery ratio, throughput and delay. Let us see the output of our project. First, to open terminal window. The terminal window, type cd space, the folder name, what you have, that project. Then type ns space main.tcl. So distance between the node is calculated because we have to select AN node and cluster head node. So the shortest distance node is set as AN and as well as cluster head. So this is our output. So out.nam is nothing but the network animator window. When we click play forward button, this is for simulation speed. So now our target is moved from somewhere. So these four nodes are act as CH nodes. So now if it so the information this 23 node of 23 is add as an aggregation node and collect the information from that tracking node and sends the information to the destination via cluster head. Cluster head node sends the information, that is the data packets, to sink. If the target tracking node moved somewhere, then another AN is selected and it sends the data via cluster head. So another AN is selected. So 12 is selected as AN and it sends the information via that cluster head. So it sends the information. There is 13 is receiver and 18 is sender. So it receives the information. So for graph, type GNU plot space thr.plot. Open terminal window, cd space code final GNU plot space delay.plot. So delay is measured by the unit of millisecond. So in existing system they produce more delay compared to our existing system.